So I wanted to talk about Mobius strips and what people seem to get wrong with them. So the traditional explanation of a Mobius strip is that you take a strip of paper and you imagine it's a 2D plane, and you take this plane, you add a twist into it, and this gives you an object that only has one side, meaning that you can trace around and you'll come back to the other side, and there's only one side to the object. But here's the thing about 2D objects. 2D objects only have one side to begin with. So I think a better way to model 2D objects is with a transparency. This probably doesn't show up very well. But if we take a transparency, this better represents what a 2D object is, because a 2D object, if you draw a line on one side, it's going to appear on the other side because it doesn't have another side. It only has one side to begin with. So this whole thing with taking a Mobius strip and declaring that it only has one side, well, it only had one side to begin with because there's 2 dimensions. It's just kind of funny. So with modeling it with a piece of transparency, it already has one side to begin with. When you draw on it, the line appears. When you rotate it in 3D space, you'll see it on both sides. And you can still do the Mobius strip thing, but it ends up having a different meaning, I think. Now, so then you have another type of object, which is a Mobius strip in 3 dimensions. Because in 3-dimensional space, and it does have this property that you can only, if you just make a loop out of a piece of paper, then you can draw on one side and then it has another side. These are 2 different objects. Because it has a 3rd dimension, it has 2 different sides to begin with. So there's 2 different things that are always being talked about, but they get conflated into one. A way to illustrate this is through topology. You can take this is another way to make a Mobius strip. What you do is you take a piece of paper and you cut a slit in it like this, and then you fold around like so, and we get a Mobius strip without the twist in it. It still has a property where you can go around and there's only one side to it. There's only one side. And what's interesting is that it's like a pair of pants. So the pair of pants has the distinction that it has a front side and a back side to begin with, because it's a 3D object, and the 3D object has thickness. It's an important distinction. It doesn't get made when we're talking about Mobius strips. The thickness of the paper matters.